This year, we are celebrating the International Compost Awareness Week together with the International Compost Alliance from the 3rd to the 9th of May. This is always the first week in May where we are celebrating around the world the International Compost Awareness Week. The International Compost Alliance is a global network of compost organizations, and we promote composting as a practical solution for healthier soils, resource recovery, and environmental sustainability. The founding members of the International Compost Alliance are the Australian Organics Recycling Association, the Compost Council of Canada, the European Compost Network, so we, but also included is the International Solid Waste Association with their working group on biological treatment. The Italian Compost and Biogas Association, CREAS, the Composting and Anaerobic Digestion Association of Ireland, both are also members of ECN. The Organics Recycling Association of South Africa, the Association for Renewable Energy and Clean Technology from UK, REA, Waste Mints from New Zealand, and as well as the United Compost Council from the United States, and the Compost Research Education from Foundation, which always organize as well the compost contest of the International Compost Awareness Week. Together with our partner organizations of the International Compost Alliance Week, we launched a global call to action for the International Compost Awareness Week, urging governments, industry, educators, and households to recognize and prioritize compost as a strategic resource for soil health, food production, and climate resilience. This year's theme, Compost Feeds the Soil That Feed Us, highlights the role of compost returning valuable organic matter and essential nutrients to soils and keeping our natural soil systems fertile and healthy for food production. Our campaign comes at a time of growing pressure on agricultural and land management systems, including rising concerns over the cost and availability of mineral fertilizers, which are mainly based on fossil fuels. Against that background, composting should be viewed as more than a valuable waste treatment solution, but as an increasingly fundamental source of nutrients and carbon for soils. As input and energy costs rise and supply chains remain vulnerable to geopolitical and economic disruption, compost is drawing greater attention as a practical and local tool to help build soil fertility, nutrient resilience, and long-term productivity. Compost contribution extends well beyond nutrient supply. By improving soil structure, moisture retention, and biological activity, compost can help soils perform better under pressure from drought, erosion, land degradation, and other climate-related stresses. On behalf of ECN, we would like to contribute to this important topic with facts and figures from long-term trials of compost use. Over the last months, our project officer, Olivier Labrie, has studied and assessed the results of long-term trials with compost and has compiled these results in 2 new fact sheets to demonstrate the evidence on soil health of compost use and to give economic and economic advices to farmers. These will be presented today. So now we are joining, or I'm handing over to Olivier, who will present these results. And please keep your question in mind, put them into the chat, and we will discuss them later afterwards. So Olivier, it's your turn.
Thank you, Stephanie, for the wonderful introduction to the International Compost Awareness Week and for introducing the topic so well. And I welcome everyone today, this afternoon. I hope there are people from across the globe, given that ECN has such an international network. That would be very exciting to hear from where you're coming from, maybe at some point. And as Stephanie touched upon, compost has become more and more relevant, especially in today's context, in geopolitical concerns and in ecological concerns. And as she mentioned, we've been doing a lot of work as a team to look into what the science has to say and what long-term trials directly from partners, what's going on there, and understanding and taking the evidence and the insights from them, and we put that together for you today. And we realized that in order to provide sustainable soil management in Europe, we have to look at the long term. So that's what our fact sheets focused on, and that's what we'll be getting into today to celebrate the International Compost Awareness Week. So yeah, we can dive into the next slide. So just to kind of get an understanding of where things start, I wanted to provide you with an overview of where the compost that we work with comes from, and that's bio-waste, so from kitchen scraps, also from green waste, from scraps in the garden, that we all produce, you, myself, your neighbor. And as you see on that map, there's an abundance of bio-waste being produced Europe-wide on a yearly basis, to the amounts of 120 to 140 million tons per year. And unfortunately, that only around 50% of that total amount is currently being recycled into compost and digestate products. So out of that 40%, around, you can give me the next, 42 million tons of biowaste is transformed into compost, which equates about 21 million tons. Now, if we were to look at agriculture, the available arable agricultural land in Europe, and wonder, okay, how much land could we cover with that amount of compost? It would be approximately 1.5 to 2% of arable land in Europe, which is an important contribution. And I think the note here is that it could be a lot more. It could be up to 5%, even maybe 7%, with given the current amount of biowaste being generated in Europe. And that's if we if the biowaste that's being collected, that more of it is being collected, and that's being collected to a high level of quality so that it can be transformed into a quality compost product to be added to agricultural soils. So really what we want to be doing is scaling the quality of biowaste collection across Europe to unlock millions more tons of compost for agricultural soils. Next. And so ECN is also working on the Fertility project. This is an EU-funded project, and we have a consortium with partners across Europe. And so we bring in our expertise on bio-waste and food waste compost, as well as anaerobic digestate. And I just wanted to show you a bit of the data that we've collected from that project to show you now from a data perspective that indeed a lot of biowaste is being generated in all EU member states at different amounts. But as you can see in the amount that is separately collected, it's always less. Now, so there is, of course, the aspect of the quantity that's there, but it's also a reality in terms of the access, because there's only so much that's being supplied in each member state. And I must say also there's a question of farmer demand that plays a role in that as well, but this is what we're here for, and bringing awareness to what compost adds to soils and why it's important to close that feedstock gap. Next. So what we realized, we essentially synthesized data and from long-term field trials in the scientific literature and from our ECN partners, our members, and the results were quite clear that compost contributes to all soil health parameters, and it improves them in every case. Not every study or field trial covered all soil health parameters, but this was the work we did, is we brought all that together to show that in every case it was improving. And that really gave us the confidence to say that can be a key solution to the soil health challenge in Europe, especially in the context that there are increasing pressure on agricultural soils in Europe and worldwide, in terms of degradation, erosion, and loss of soil of organic matter. And this is even intensified as climate change exacerbates these pressures through droughts and extreme weather events. So what soil really needs is support from available resources. And we have the resources available across Europe in the form of bio-waste and green waste, and they essentially need to be made available and accessible to farmers. Next. Now I'll get a bit more about why long-term evidence is essential. Compost is a soil mender, and it acts quite differently than pure nutrient-based fertilizers. So comparing them in the short term is, let's say, it's like comparing apples and oranges. So they're two very different things. But what we found is that the benefits really arise in the long term. So compost behaves in a way that it pools and releases nutrients over the long term, and that these accumulate over the long term, and nutrients that were there in past years then are released later on as well. And that the benefits of compost application to soils really occur over years and not in a single season. So yeah, we just needed the long-term data to understand the lasting effects on soil health and be able to compare that and understand that how that stands up with mineral fertilizers. Next. So as I mentioned earlier, we saw consistent improvements in soil health across the trials. And if you want to go a bit more into the details, our fact sheets are online on the ECN website for you to look through the details. I won't go into all of them here for you, but yeah, the key findings were very interesting in terms of the repeat long-term application of compost on a yearly basis. We found that soil organic matter consistently was maintained or increased in soils, which led to improved soil structure and the soil food web. And the same had to be said about soil organic carbon, which stabilized at some point in the form of organic carbon in soils. So not only did it have a climatic effect, but it also improved the structure and the function of the soil as well. And these two things necessarily led to an improvement in water or soil porosity and the ability for soils to retain water, and for crops to be more drought resilient over time. And yeah, and all these changes to the soil, fed into the fact that it was just a better habitat for the soil biodiversity, so the microbes and the fungi, and they themselves kind of have a positive feedback into all of this by further supporting soil structure and nutrient supply, which I'll get into a bit more later. All the studies show that there was compost over time provided reliable, steady supply of available nutrients for crops, and it showed no significant accumulation of impurities or heavy metals after long-term use. And all of these things essentially led to supporting stable crop yields and also improving their quality over time, which was really interesting to see. We also wanted to visually give you kind of a feeling of what that difference looks like between mineral fertilizers and compost. So we all are probably quite aware with the benefits of mineral fertilizers, that they have this immediate nutrient availability. So they contribute, of course, to crop yield and crop health in the short term, but that they need to be reapplied every year in order to sustain that. And their contribution to soil health is rather negligible. So in that sense, that's where compost kind of comes in and has a strong role to play, because if farmers manage to stick to compost over the year, they will see several different benefits to their soils in terms of the chemical, the physical, and the biological properties of their soil over the time, really supporting living soils and not, yeah, and yeah, that's what they will be supporting over time. Thanks. Next. And the mechanism that's supporting all of this and kind of, yeah, I would say really supporting the nutrient supply for the crops and the activity in the soil is the fact that compost contains a large amount of organic matter, which is really the foundation for soil fertility. And that nutrient-rich organic matter. It stimulates a self-sustaining nutrient cycle within the soil. So essentially, when farmers add compost every year to their soils, they're adding this nutrient-rich organic matter, which feeds the soil organisms, and so the biology populations grow, and they start interacting more and more with that organic matter, which allows more nutrients that were previously bound to organic matter to be mobilized and available for plant uptake. And as those plants grow and they produce a stronger root system, those roots return carbon to the soil in the form of root exudates, and which then feeds the soil microbiology and the soil life. So if you keep doing that, if farmers keep doing that, then they're essentially they're providing new food for this cycle. And to kind of show you a bit about like what that would look like from a data perspective and what that potential is in terms of a nutrient supply over time. As I stated before, it's in the short term, you really don't understand what compost potential is in terms of nutrient supply. As you can see in this chart, nitrogen supply, as most of us should know, that in compost is relatively low, speaking in the first year. But as we get to year 5 and beyond year 5, nitrogen, phosphorus, it slowly is released from compost applications in previous years. So it's not only is there the nitrogen and the phosphorus from that given year, there is also the nitrogen and phosphorus that's being released from the mechanism that I just spoke of in the previous compost applications, and more is it the compost overall over time can contribute to the crop nutrient demand. And that is quite interesting. That's quite an interesting message there for farmers, because that would mean that, especially in the context today where mineral fertilizer prices are really increasing, that there would be less and less of a need for mineral fertilizer top-ups over time, which we can see here in the chart. And that would essentially reduce their dependency on their mineral fertilizers over time. Next. It was also important for us to look into the economic benefits of a farm. So both of these, what I showed in the last chart and this chart here, these are models. So these are based on the nutrient composition of our member compost, and we wanted to understand what could be the best case scenario if all things were to align in terms of climate, weather, and management practices. And this is looking at the long-term cost projection of a fertilizer plan for NP and K with compost and mineral applications. And here you can see that there are kind of these bands that are going across the chart. Those are representing two different application rates of 10 tons per hectare and 15 tons per hectare, with low, median, and high mineralization rates of nitrogen, as well as different availabilities of phosphorus and potassium of 80% and 50%. And versus this mineral-only baseline on a farm that would only use mineral fertilizers. And what we can see here is that by year 5 to 10, that the farmer is essentially able to reduce its cost to a point where it's the same as the mineral baseline. So there's the initial additional cost of compost application on top of mineral fertilizer, but as there's a reduction in need of mineral top-ups over time, eventually past those years, then there will even be a cost reduction for the farm on an annual basis, in this model. So this was really important for us to be able to understand whether it is possible, and based on the model, it technically is possible, of course, depending on conditions. But we found this to be a very interesting insight. Next. And just to share with you a concrete example from one of our members in Italy, Chick. They've developed the Navarre project in collaboration with the University of Bologna. And this is one of the long-term trials that we've included in the fact sheets, amongst others. But I just wanted to show you kind of an example here today and what the findings were from this specific project. So it started in 2018, and they were wanting to investigate the fertilizing efficiency and the main effects on the soil following the use of compost soil improvers. And what they found was that, I can show the chart now, that there was an increase in soil organic carbon in all the plots that were treated with compost. And in comparison to 2018, there was an average increase of 75% in soil organic carbon in the yearly treated plots. So that kind of goes back to the whole message that I've been sharing with you today. Of course, it's also interesting to apply compost, let's say in a 3-year rotation, but through the yearly application, there was a clear benefit there in terms of soil organic carbon, and that they saw the highest organic carbon conservation in their more stable products, which is a solid digestate product. They also looked at yield. They wanted to understand what were the yield differences between compost amended plots and minerally fertilized plots. And interestingly enough, they found that there was no statistical difference between those plots. So until today, so that was a very interesting thing to say. So I think it goes back to say that compost clearly has a strong contribution for soil health and nutrient supply over time through those mechanisms that I spoke about. Next. Now, of course, there are a number of the long-term field trials, the farmers, there are a number of considerations to take when applying compost and using compost. This can all be worked out quite easily with consultant or the plant operators. Usually have consultants working with them to help farmers understand and integrate that into their fertilization plan. What's really important is the rate of application. That's sometimes determined by national regulations, depending on the EU state, and also the timing, at what point in the season they can apply the compost on their fields. Other important considerations are, of course, soil and weather and nutrient leaching. So there it's important to rapidly incorporate compost into soils, also to avoid emissions and odor. So it's maybe different than what most farmers are used to when only using mineral fertilizers, but it's something that's quite readily supported and used, and there are many farmers who've been using it over decades in different parts of Europe. So with each concern, there's really always a solution involved. Next. And again, we want to promote compost. We're all here to promote compost, and it's also important to understand, okay, what is possible in order to increase the availability and the use of compost and really scale it to a point that it's making an impact in many corners around Europe and really contributing to soil and sustainable farm management. So there are, of course, a number of current barriers, but also enablers. So with every barrier, it can also be seen as an enabler if you look for solutions in it. As I mentioned, so there's, of course, a limited collection of quality feedstock. That's bio-waste, but there's a lot already being collected, a quality feedstock that's being collected, and there's a lot of quality compost that's being produced and used by long-term customers, clients. And yeah, treatment capacities is, of course, a topic, whether facilities, what kind of treatment, how much they can treat on a daily basis. It's always the goal then to increase or improve the capacity and the amount that's being processed over time. There is also a lack of awareness amongst farmers in terms of the benefits and the value of compost. And I think again, there's in hand with the enabler farmer engagement and knowledge sharing. So farmers that have used compost over the years and have demonstrated and experienced themselves the benefits, get their voices out there and bring more awareness and attention to the benefits of compost for soil health over time. So yeah, there's actually in some places there's a supply issue. There's compost, the available compost is given to long-standing customers, and there are more and more farmers that are wanting compost, especially in areas of suffering from drought and organic matter loss. So yeah, we need to get more of that feedstock, clean quality feedstock to plant operators so that farmers can benefit from it. There's of course some questions surrounding compost, and there's, of course, it's an additional cost, but I think if we can really get the message across that investing in the long term will fundamentally sustain the soils, and that's really an investment in the farm operation itself, that it will pay itself over time. So it's scaling compost requires regional and systemic level change. It includes yourselves, it includes citizen engagement, providing clean kitchen scraps for the bio bin. It includes improved collection systems, policy support, and harmonization amongst directives and regulations. And that's Aline, our policy officer, is working on that quite strongly. And yeah, as I mentioned before, farmers' engagement and knowledge sharing, which is really key. I think we need to get farmers' voices out there more and more. Next slide. So kind of summarizing everything, what is compost contribution to sustainable soils? If we take all the key messages from today, it's about utilizing locally and abundant resources, and it also contributes to utilizing established and EU-wide technology. There's the knowledge for it and there's the equipment for it, and it's being continuously developed. It contributes to a reduction in the use of valuable natural resources, to the long-term soil health and nutrient cycling at a regional and soil level. Over time, it can contribute to farm cost reductions and reduce mineral fertilizer dependency, and in turn, overall, all of these essentially promote the farm sustainability over the long term. So I'd like to thank you for your attention. I hope that you might dive into the fact sheets after this or over the coming days to look a bit more at the evidence that we've collected for you and the public, to really demonstrate that compost over the long term, it is a clear contributor to soil health and to soil function and nutrient supply for crops over time, and that it's an available resource that can be better utilized. It's being already very well utilized and can be improved, and this is our goal. And that has, yeah, it really is a strong contributor to sustainable soil management and farm resilience, which is really essential to feed us all. And I'll pass the word over to Stephanie now.
Thank you very much, Olivier, for this good presentation. So far, I do not see any question in the chat, but we are a small round. So if there are questions from your side, please post your question. But there's a question from Susan Tao. Hello from Canada. I'm wondering if Europe permits the land application of digestate as a soil amendment, and whether they test for PFAS, and what are we doing about biosolids that contains municipal sewage sludge? Olivier, do you want to respond to this?
Would you be able to respond to that more specifically on digestate?
Yeah, so
would you have a better overview?
Yes, I have a better overview probably on the use of digestate. So in general, we support the use of quality assured compost and digestate. So we know as well that quality assurance is essential for waste derived products. So We have in several countries in Europe quality assurance schemes in place. That means that the products are controlled regular on heavy metals, on nutrients, so that we can make also a clear calculation of the nutrients and so on, and to give the right application. In general, there's not, we have different regulations in Europe across the countries, but in principle, it's not forbidden to use digestate directly on land. So we are talking here about digestate from agricultural residues and from separately collected bio-waste. So when we speak about quality assurance, we do not include as an input material sewage sludge. So we exclude some contaminations which are not in a huge amount in bio-waste included. So in principle, we do not have a problem on this. We know as well we have some member states which have also criteria for the input materials. They are controlling as well organic substances in the input materials before the material goes into the treatment process. And then in other countries, we have also monitoring system where the materials are looked for these particles like PFAS, organic compounds, and so on. So with these quality assurance in schemes which are in place, we are sure that these can be safely used, these products. So we are not covering sewage sludge, and the reason why we do not include in our quality assurance scheme sludge as an input, sewage sludge as an input material is because there's unknown risk about the pollution in the sewage sludge. So it might cover more parameters you have to control in the quality assurance scheme, and then this makes it very costly. Okay. There is a question from Seattle. If 30 or 60 tons per hectare were applied, would that achieve faster cost benefits? This question I will give over to you, Olivier, because you did the calculation. So this means
How
if
many
you
tons, sorry?
30 to 60 tons, so 30 or 60, so much more than you have calculated with the normal application rate we use here with 10 or 15 tons of fresh matter in Europe.
That's a very good question. I mean, we don't have to go back to the chart, but if we look at the other chart, the application rate of 15 tons per hectare, it did achieve, it did cross that baseline more rapidly. So theoretically, yes, it would be possible. It's always a question of which country are we talking about? What are the prices there? So it's always like a case-by-case scenario. I would say that yes, the soil health benefits would improve likely quicker. Therefore, you would have a greater immediate and maybe short-term to medium-term nutrient supply versus these scenario. So yes, theoretically that is possible. I think there are just other considerations maybe to take into consideration as well. What type of soils are we dealing with? What are the national regulations in terms of the application rate in that country? So these two application rates, I followed the standard for Germany because there are the restrictions on the amount of phosphorus that can be applied to agricultural soils on a yearly basis, and therefore they have a strict application rate that on an ongoing 3-year rotation. So I kind of use that as the kind of conservative estimate, but I know that there are other countries, I believe in Italy, there are cases where they're applying 50 tons or so per hectare and have seen benefits, but it's always the question of the type of compost, the feedstock, and what are the nutrients that are available? What are they doing? And what are the soils? How is the soil interacting with the compost?
So we have two further remarks in the chat. One remark from Morten. Hello, Morten. Nice to hear from you. Morten he will provide us a further scientific work from Denmark, where also PFAS were analyzed in compost and digestate. So these results would be also valuable for us. Probably also for your information, we have also in ECN different task group. We have also a task group on quality assurance and the task group on quality will focus this year as well on PFAS, on other organic pollutants, on herbicides, and as well on the issue of microplastic, which is all over the world a topic. So we discuss these topics as well internally in ECN with our members. So we are happy to receive information from your side. If you have scientific studies on this issue, please share this with us. This is valuable information material for us. Then there's a remark from Julie Christensen. Looking at the results of adding compost, I would expect differences in effect depending on soil and climate. Soil in Italy or Scandinavia. This will be important when making averages. Probably I can respond to this as well. We are aware that these are differences. This is not only related to climate, it's also related to the soil type. So it's clear that if you have a sandy soil, it is more difficult to improve the organic matter content in the soil because you do not have this capacity for exchanging these clay minerals, which you have in silty or more heavier soil. This is clear. A very dedicated study was done by ICAW. There are the ICAW reports on the benefits of the use of compost and lysostate on soil, which were worked out by Jane Gilbert and by Marco Ricci. And there are given also the different application rates or the different results from the different soil types and so on. And you will also see in our fact sheets that we are not only focusing on the on the medium-term study from Italy. We have different long-term studies included in the fact sheets, where you can see that there's also a variation in the amount of carbon which is stored in soil or how it influences microbiological activity, which is also always related also to the soil type and to the climate, and for sure as well to the water content you have in your soil. This is clear, but you see these averages as well in detail in the fact sheets. But Olivier, do you want to give some more information on this point?
Yeah, that's an important point and something that we discussed while creating the fact sheets, especially with our partner in Italy. He mentioned how the mineralization rate of nitrogen was much higher in Mediterranean climates and that it would be very different in Scandinavian or northern climates as well. So this is what I tried to take into consideration. That's why I did kind of low, median, high, and I think there could always be lower lows or higher highs in terms of nutrient availability and mineralization, of course. But this, I think, provides a pretty good idea of the possibilities and that change over time.
Okay, and then we have a last question from Rafael Caceres from Catalonia. Thanks so much for your presentation, Olivier. I would ask you about the specific knowledge needed, technical, scientific, or economic, to boost the use of compost in Europe.
Yeah, I guess that's a very good question. I guess that kind of goes back to one of the slides where I talked about it needs change at every level. I mean, change can happen by educating a child. It can change by one's own behavior or neighbors. It can be changed by the work that ECN is doing and also probably the work that you're doing. I think one thing that might be important in the future is really to take, because essentially there are two things that are needed is, of course, the improved quality of feedstock so that more feedstock can be processed, but on the other end, the trust of farmers. And I think the more farmers' voices that we get out there, and maybe the more that they're heard also at EU level, and sharing their experiences and the benefits that they've experienced and the positive aspects that they've experienced on their farms, I think that would be of tremendous benefits and things that could be included in reports or fact sheets on social media, etc.
Here, I would like to stress again that when we use as well quality assurance, we always have a certificate with all analytical results, and we can provide really the nutrient content to the farmers. We can give also application plans to the farmers, to the specific crops, which are based on the availability of the nutrients in the compost. So this is more or less available, but it needs that the farmers take this up and that they're also educated by their studies for using recycled organic materials for fertilizing their soils and their plants. I do not see any further questions in the chat. I hope I have not overseen anything. If there's any question you want to pose, you have the possibility to do it now directly if you like. Otherwise, I will come to the closing remarks. I do not see any further remarks. I do not see any hands, so I will go further. Sorry for this. Okay, my closing remarks. So thank you very much, Olivier, for the presentation and for giving us the insights from these long field trials. What we can see is that compost and anaerobic digestion of biowaste are well-established technologies to recycle organic matter and nutrients. So we have different technologies in place for composting and as well for anaerobic digestion, and they can always be adapted to local conditions. You always have to look as well to what feedstocks are there. Do you have only green waste? Then it's clear composting is the best choice. If you are dealing with food waste, then anaerobic digestion might be more important for you because you can also earn the energy out of this material. And a combination of both is always good because you have at there and an organic rich material compost which can be applied more or less to all soils. So the technologies are there. The feedstock availability is also there. The experience is there. So we have many plants in Europe. We have a lot of also farmers, organic farmers, but also conventional farmers, which use still compost in several years. This is also shown in these long field trials. So the knowledge is there, but it has to be used. What we need as well, as we know, we only want to place quality materials on the market, high quality materials, and we can only achieve high quality compost if we do separate collection of bio-waste. So we cannot deal with mixed waste compost. With mixed waste, you will never reach a high quality product. So this is a precondition, and we are happy that we have on European level the European Waste Framework Directive, where the member states are obliged to implement separate collection. So a lot of member states are still in the implementation phase of the separate collection of bio-waste, and also the municipalities have to follow this strategy. Otherwise, we will not have a clean input material which can be used for the production of high-quality compost and digestate. We have always to raise awareness also for our citizens that they also do a better sorting in their households. We need very good input material without any plastics. And we also need that they put into their food residues, which are leftovers, to the biobin. This is also very important. We need this source for recycling of nutrients. Then we need the recognition from the farmers that compost and digestate are valuable materials, organic soil improvers, and organic fertilizers, which can be sustainably used on land. But in addition to these requirements, we need as well legislative support. We have to support calm farming practices. We are happy in Europe that we have now the certification framework for carbon removals, where the use of recycled compost and digestate materials are recognized as a common farming practice. We hope as well that in the implementation of the common agricultural policy, eco-schemes will be set up where the use of recycled derived fertilizing products will be supported. This has to be done in national common agricultural plans, and the member states has much more flexibility in the new common agricultural plan in 2028 to 2034 to take up these to set up these eco-schemes for bio-waste derived fertilizing products. But what we need in addition, and this is at the moment as well on the agenda of the Commission, we need also to support material recycling to really recover the nutrients and the organic matter. And therefore, from our point of view, we need a nutrient recycling target for bio-waste derived products. And I hope that the Commission will consider this as well in their new proposals for the Circular Economy Act and for the Fertilizer Action Plan, which are at the moment under discussion. discussion. So these are my closing remarks. I hope you found our webinar interesting, the presentation of Olivier. Please visit our website. You will find more information there. You can also download the fact sheet there. But I would also invite you to join the ICAW website of the International Compost Alliance, where you find further resources on information from Canada, from US, from UK. And please join as well the other webinars this week, which are organized by Canada, by US. And yeah, I hope to see you soon back for a further webinar to discuss this topic on the benefits of compost in Dutch state. Goodbye. Have a good day and celebrate the International Compost Awareness Week.